Okay, so good afternoon. So welcome to the 37th TrustML Young Scientist Seminar. So I'm Sugiyama. I'm chairing the session today. So today we have a nice visitor guest speaker. So Professor David Che from KAIST. So let me briefly introduce himself. So Professor Che got a PhD in computer science from the University of Illinois at Urbana-Champaign in 2012. Then after that, he became an assistant professor in UNIST in Ulsan. Then he became an associate professor also there. Rising star, distinguished professor there. Then after that, since September 2019, so he's now an associate professor, tenured associate professor of Graduate School of AI at KAIST. And also he's a director of Explainable Artificial Intelligence Center established by the Ministry of Science and ICT in Korea. So his major is Explainable AI, of course. And the title of his talk today is also Explainable AI, Academic Research and Industrial Applications in Korea. Okay, Jessic, so we are looking forward to your talk.
Okay. Thanks for nice introduction, Professor Sugiyama. It's my great honor to be here in Tokyo and also Weekend AIP Center. So this is my first time to be in Tokyo. So I have a couple of flight exchange in Haneda, Narita Airport, but this is really central of the city. And I'll try to start my talk. So one of the issues that we wish to study for the explainable AI is to understand the internal mechanism of AI model, right? So then as we observe the Uber car and also Tesla car, autonomous car make the accident. But as AI system become more complex and we are using more non-deterministic or very hard to diagnose or analyze AI model like a deep neural network model. So it is extremely hard sometimes to find the reason of these failure. So this is one of my view for explainable AI, the reason of why we need explainable AI. So if you think about existing system, so many of those systems are deterministic, like smartphone or TV and car and so on under some conditions. So those functions are deterministic. So meaning that whenever we put some like a number or force, then the results are like determined. So that functionality can be verified by the specification of the spec that provide the design, and the customer can use the service and get the satisfaction. But if we come to the AI model, AI like era, then there are two issues. So one is, so AI model are fully or partially autonomous. So one of the example is, so when we are making the AI dialogue system, and those dialogue are not deterministic. Sometimes we say hi, then they say hi or hello, and what's the weather, and so on. So those autonomous parts are kind of either probabilistic or non-deterministic. And another part is, even though those functionality are deterministic, so we are very hard to find the like specific like procedure that is encoded inside the AI. So if we cannot actually open those like algorithm well, then the result is very similar, like autonomous, fully or partially autonomous part. So we are not like open all the deterministic part of the algorithm. So as we collaborate with people in this situation, so even if the AI system gives the functionality and the verification cannot be done by the certification, but also explanation of decision of AI is necessary. So we may need to ask, why did you make decision A? or B or C, and why not A, and so on. So in that case, so we need to have more like interface or analysis and also communication with AI why this specific decision is made. So I think that is one of the very important change when we use more AI service, which is more important autonomous or more complex system in the mission critical system. So like as DARPA say, the explainable AI is very important for we to understand why we why the AI model make that decision when not making the other alternative, and when those functionality can succeed, when this can be failed, and so on, right? So that is actually one of the important issue. And also like as a customer, so many customer are curious about the like why this like a decision is made by the internet platform provider like Google or Amazon and Apple and so on, because they use their data and use that for their cost like a customer like a service like advertisement and other recommendation and so on. So EU make a strict regulation for the GDPR, and the one of the like a regulation part is when customer request to make a like a request or explanation, and those providers should get the like explanation, and if they fail to do that, then they are fined for up to 4% of global revenue. And like recently, like they increased those into the high risk AI, including the biosensors and autonomous car and the credit rating and the other like one. So for the high risk AI, so when the decision is not explained very well, then they can get the 6% of total global revenue as a fine. So if you imagine that, so if you're a CEO of those company, then you may be very like worried about those situation. Like I think the Tesla Motors and also other like car maker as a autonomous driving system, also many banks, and also the internet provider, like platform provider who make continuous digital marketing need actually those explanation for the decision or recommendation or this like autonomous driving that they have because the increased fine. And because of that, the like Stanford also like say in the human-centered AI, they say trustworthy AI is very important. And also Deloitte say trustworthy, including the fairness and the robustness, privacy, safety, responsible and transparency, explainable AI is important. But I think actually in my personal view, so probably in terms of AI and the mathematical view, the explainable AI and the fairness is one of the like core parts that we can AI researcher to contribute. So like as other countries do, the US also emphasize that so there are three waves in the AI funding or AI like research. The first one is describing the whole world like expert system, handcrafted knowledge, and also second one is the statistical learning for the categorize either cat and dog and so on. And the third one is like the new way for the explainable AI with contextual adaptation. So like I know that Riken is doing a lot of fundamental research to detect and understand the bias in the training data, also the machine learning model, but that is also very important when we have a contextual adaptation with diffusion learning and so on. But in here, so explainable AI and those research are important. So when a young boy is holding a baseball bat, that is an automatic captioning from the computer AI model, that we should identify why the toothbrush is misspelled as like a misrecognized as a baseball bat. And also when panda is come and we have a very like small noise, but still the image is panda, but the AI model is recognized as a given, then we should know this why this is the case. So this type of like example is very famous as adversarial attack. So when you have a stop sign and someone come and put the 3 sticker, and like a AI car model misrecognized it as like a blue like a light. And the type of example are like many. So of course we have a view that understanding the semantic boundary in terms of decision boundary like is very important for that, but there are a lot of research in there. So in EU, the XAI initiative is also very famous. Like there are a lot of research in the ABB. Oh yeah. And also like we are doing intensive research collaboration with TU Berlin and the Berlin Big Data Center with Professor Klaus Müller and so on. So that is also very important in EU. And this is one of the examples that the input attribution method in explainable AI can be used. So this is a pilot net made by NVIDIA and the Google research team. And the image come and output is the one of the 10 angle of the steering wheel. Then like 4 different steering wheel, then we can identify why this pilot net make the decision by like painting with the green like a color on top of the image. So when the like the steering wheel is going to turning left, and when steering wheel wish to go to like a straight and wish to go like a right turn, then this is the like a green light for like highlight this. So this is very important functionality, and also in terms of functionality in 2 parts. The accurate prediction and the accurate attribution computation of the contribution of individual input. So sometimes it is like easy, but sometimes it can be difficult. But there is also one important like a technique, and the other technique is interface. How we can explain those into the human visual or communication interface. So in here, so if we have the choice, then you are buying a autonomous car, then the one car has this functionality, like putting green light. And the other car doesn't have this functionality, just actually going like moving their own and does not saying anything to the driver, like the passenger. Then probably most of customer may choose the car with this type of explaining functionality, because at least at the beginning, we are not so sure how this AI is good, or AI can be like a misfunction and so on. For example, if there is some dust come to our camera, and that for this vehicle, then we are not so sure whether this like moving correctly or not. So this type of functionality is important. So like so as an example, then the Bosch is very important, like famous for the electrical part maker, and they say that in the AI center, their goal is to try to make safe, secure, robust, and explainable AI, because they wish to make a smart, connected, autonomous like AI for the car. So this is also the venture capitalist investment explainable AI. So in Japan also the SkyDisk is a company who make like a explainable AI system to diagnosis to like a auto like a car part maker. So then when the car part is made, then they are like a real time analysis whether the part is good or not, because of which region and so on, is a visual interface with explainable AI. And also the Anthropic is a very famous startup. In probably you may remember the Google Deep Dream. So the Google Deep Dream project is try to emphasize which individual unit is activated by making an example from the input image. So when input image is made, and the special unit is highly activated, then how we can make this type of image. So when the image is for the flower, then if you make an image, then the many flower is generated and so on. So that like the startup team, including some of those members with like Google and OpenAI, make a huge funding at the first round. Like And in the explainable AI program in Korea, that fortunately that I could lead for last 5 years, and we could continue for next 5 years. And the Professor Masashi gave the recommendation letter for us. So I'm also thankful to the support from Professor Masashi at that time, and also wish to make a solid country like a collaboration with we can at least in terms of not only for the explainable AI, for trustworthy AI and so on. So we could like host some of the workshop, and like I will also make item workshop with Professor Klaus Müller next January, from January 9th to 13th, from in UCLA. So that is actually a good chance to make many people in the explainable AI, not only for the mathematical science, but also other field of science to use explainable AI. And good opportunity for the tutorial for many young researchers. So I will send another like a flyer for that. And so our goal is to make the deep learning more transparent. So of course, there is a very challenging problem. We could make those like this is our explainable AI team for the last 5 years, and so we could host some of the like tutorials and workshop, and we also have a plan to make workshop in next ICML, which will be held in Hawaii. And also next year in Korea. So we'll continue to make like gathering for explainable AI and trustworthy. So in last 3 years, so in the center there are about 250 registered students and researchers, and about 20 PI in the project, and we could write about 130 top conference AI conference papers and the journal papers and so on. So my paper is only a few of those, but we have a very nice research scholar like Professor Klaus Müller and the Sungwan Lee and the Jinwoo Shin and the Song Hwang and so on. So they like do a lot of good research, and the book is edited by the like Bochek Samek, Professor Bochek Samek and the Klaus Müller, and I used that book as a graduate study in my school. And we also did a lot of industrial project to make the company in Korea to use explainable AI for their procedure. So for example, POSCO use explainable AI for their smart blast furnace, and the Samsung Semiconductor and the electronic, and use those technique to diagnose their like contamination of air in the fab room. And like some of our team member like extensively put the healthcare approach to monitor patient in the ICU unit, and some like a financial company and bank try to make their credit ranking system explainable by recent algorithm and so on. Yep. So that is I write with David Gunning in DARPA for the positioning article. And explainable AI, we can divide that into the like roughly 3 groups. So one is interpretable model, composition of those. And our human language is very similar to this. So we can understand individual like a word and the composition of the word as a sentence, and like set of sentence can be like form some of meaning and the relation and so on. So if we make those like a formal language-like system can be interpretable, then that is actually one way to learn some model. And of course, recently one of the most intensive area for research is deep learning. So how we can make accurate input attribution computation for deep learning, and also how we can analyze internal mechanism of deep neural network. So we can understand some internal unit are not well trained, and some unit are like what is the function of internal unit and so on. And the other like very famous approach is model agnostic method like shape and the line and so on. But these type of methods are kind of less accurate. So I could not see many examples that these methods are used in the call like a real-time system in the commercial system and so on. But actually, like this model agnostic system is very good to understand the mechanism. So if you say then explainability and the learning performance, then we can put those model into the explainability and the performance trade-off. But explainability, I wish to improve those both. So one example that our team did in the there is actual work led by Professor Eun Yang in KAIST. And what Professor Eun Yang found is, so typical network compression say that, so their performance in the training phase and the validation phase are very similar. But so if they are not careful, then they could find that explanation as another validation method. So even if their validation score was very good, so if they compare the explanation of individual classification and many model, complex model could fail to explain the like a correct reason of this. So their approach is not only to improve maintaining the validation score, but also the complex network has a valid explanation as original model. Then in the other validations like test data, so their performance is improved. So that like not only for the validation data set, but also for the explanation of the input attribution is also very important. But I always say that this is very important IP for the autonomous car and sold this patent to the NVIDIA. But that is important, but because actually, even if we are making autonomous car and a very intelligent method, at least we need to make very like a lightweight or embedded system to make this as a neural net so to be used. But as I say, the GDPR, so GDPR require them to be explained properly. So then compression and simultaneous compression and explanation is one of the important research topic, not only for this appropriate research, but other type of more important research should be done, I think, in the future. So that is actually written in Korea, but I will try to say in English. But so we did some application of this explainable AI to the blast furnace in POSCO, and especially the end user who are board member, who operator, actually moving the blast furnace really like this approach, because previously when we make a smart blast furnace system, the system does not explain anything to the operator. Just say that the temperature will go up 1% or temperature go down 2% and so on. But like our system is not perfect. So in a way that sometimes it failed when the training data is kind of sparse or not trained very well. But in this explainable AI, say when it say the temperature will go up 2%, and it like can provide the reason to the operator, then the operator decides whether this explanation is good or not. So if the explanation is not good, then the operator decides to become the manual mode, because AI seems not very good because of lack of training data or other reasons and so on. So like we could got the like open and collaboration award for POSCO last year. So also the like international standard on XAI are initiated by from Korea. So and in this ISO and the IEC standard and the South Korean government Ministry of ICT like a lead to make the first explainable AI standard. And that is actually voted by the international members, and the working group are formed in 2021 last year, in the middle of last year. So so I heard that working group make 3 years to make the first standard, so that probably we'll see those standard in the end of next year. So and of course China and Japan and the US and other like a Partcom and Korea is one of the initiate to let's make the standard for explainable AI. And many of our like research work with industry are courted by this initiative in the explainable AI. So I will try to get into what we do in the center, and I will try to show what we do in the company. So like one of the very curious part is how deep neural network work. And that is a very challenging problem, but it's a really funny problem. So I wish to suggest many like researchers in Japan also deep dive into this problem too. So one of the famous research result that done by the MIT was network dissection. So especially for the this semantic segmentation problem, then the spatial resolution are met. So if we try to see the convolutional neural network internal part, then we can see that as we like guess, some of the neuron may be in charge of recognize some different part of the image. So then probably some channel, some unit may be in charge of making the like recognize the car or sky and so on. So that actually they realized and they found that the individual unit in the ResNet and the Google AnyNet and VGG for different like a class, they can see then the way which image are like highlight the specific channel of the unit in the level. So for example, so in the Google AnyNet, so if we open the 789 unit and this type of loop, like an image are highlighted, meaning that if this image comes, then the part of the loop it will be highlighted in the 789 channel in the inception 4E level. And also we can see that the inception 4E unit, then the 759, then this type of image are highlighted. So that it's so if we go to the 415, then this type of trend that we can see in the side are highlighted and so on. So we may have a hypothesis that probably in our brain, then some neuron are like in charge of recognize specific part of the image, right? But in here too, then we could analyze it. We could find that the specific channel and the unit be in charge of see the specific part, but not always the case. So we could actually now understand that individual unit may be may be in charge of different parts. So we try to understand more like this analysis more inside the level. So we used to make. So what if specific like a unit are activated and how we can see these actually activation. So our view was, so in the generative model, so we simply think actually this is just a generative boundary like a linear model. The difference is we may have a very huge space, like 8,000 dimension and one like 14,000 like a hyper plane and so on. So of course, this is kind of funny, but anyway, so like we don't have to worry much about nonlinear if we compare the individual layer. So what we think is actually probably our space is so previously what the people wish to see is, so if we have a proof the location, and the previous people use epsilon bound method, meaning that so in the like a unit space, try to go for the epsilon bounded space and find which example are nearby and so on. But in terms of this decision boundary like perspective, this is not really good because decision boundary itself is more important than the like neighborness like epsilon bound and so on. So we wish to make a search this area with considering the decision boundary. So motivation is generation process is well understood. So we choose a layer and a specific activation and try to find the other example in the generative model who has the same sign in the specific layer. So in this example, the similar area is the image are these, and this face is image, and we have a similar image is this. So then we define, so to solve this problem, we define some notion. So one is generative region. So generative region is, so in the generative boundary, so we can set two like a different like a region in a way that when they have the same sign of the individual vector. So for example, generative region A and B are split by the second vector, second value in the vector. And when it goes to positive, then it becomes B, and become negative, it becomes A. So all the other parts are identical. So we can say that these are equivalent set of equivalent class of G and equivalent class of image and so on. So then our problem is, given a specific like value and the activation of internal one, and try to search the like set and the set of equivalent class of image generated from the same generative boundary region. The region is when this generative region is not proper, then while we are doing search this image, we can see some of like a weird image or not so correct image are come. But if it is not the case, we can see the similar image and so on. So like this. So we solve this problem by like adopting the like a search method used in the robot planning, which is called RRT. So the problem is kind of very similar because in the robot planning there is not convex and concave or like complex area. The goal is when we wish to find the way from one point to the other point, even if there is very small hole. But RRT algorithm is famous in terms of it is complete algorithm, meaning that probabilistically complete. So if you like keep continuing using this RRT algorithm, then even if there is a very small hole, we can eventually pass through, find the path that actually through this small hole in the probabilistic version of completeness. So that we use this algorithm from the sample that we can get. So these are a lot of hyperplane. We also train some of the less important sample with Bernoulli mask optimization. And so you can see that out of all the vector, the gray one is ignored because they are not so important to making the final decision. And also now we are using RRT algorithm. So these are some of the examples that we made. And from the center of the sample point, so instead of going to the epsilon bound, we are actually using the tree which is growing to the individual direction. So if we go to the green direction and the yellow direction and the blue direction, and we can see that there are some distinction between green and yellow and blue. So can you see some difference in the green part? The green part is green part. The most of images are similar in terms of like a shape, but green part has some of the light part is more clear. So meaning that probably the decision boundary that we pass through in the green part making the light more clear than the other. And also if you see the like bottom part of the blue one, then we can see that the grass area is a little bit more bigger. And also if you go to the yellow one, then the background image is more about the yellowish, like as we see in the evening time and so on. But someone say that do we need to see those differences in the generative model? But actually, we are really like, how can I say? We are really curious about see the slight difference because sometimes these slight difference is like not so important, but in the mission critical system, like if you remember the panda and also given case and so on, then the tool that can analyze these distinction which with respect to the decision boundary, meaning the context is very important to making the like a generative like a model. So we apply this to the epsilon like the MNIST data set and also the other generative model data set, and we can see that if we search the same volume, then the epsilon compared to the epsilon bound, our method is more consistently stable and so on. So and also one interesting the research direction that we did was, so we tried to remove, I say that we use Bernoulli mask optimization to reduce this image, and we try to reduce more. So if we reduce about less than 90% of decision boundary, less important decision boundary, as you can see that original image are kept. So there are some slight difference, but their shape and color are maintained. But if the more than 90% of them are eliminated, and you can see that some of the face use glasses, and you can see the gender are changing, right? And the structure are changed a little bit more. And if you use only 5% of them, then these are maintained black hair and the black suit and a little bit bluish or a face and so on are maintained, but the genders and others are different. So that we can clearly see that whenever, given the context, which decision boundary is gone or not gone, then we can analyze whether the contribution of the individual decision boundary in the locally. So we did this research a little bit further. So what we actually did is, this is a little bit less a bit, but so we so we are living in the era of the Dali. Because we are very interested in the mission critical system like medical and manufacturing and autonomous car and so on, so we should make the generative model more stable. So meaning that, so if you see an example, then this is the face, but the face part in the left-hand side is not really proper. So we conjecture that probably the shape is either putting the hand on the face or not. They are generating the in between. So the part in the those parts are problematic. So that we use two explainable AI methods. One is we make a classifier to class the artifact, so this a classification make whether this image has artifact or not. So after that we use grad cam mask explanation. So because this artifact is detected, where the artifact is. Then after that, so this this mask is important to be analyzed. Then we also compare the individual activation of a unit, whether this mask activation part and the activation is internal unit are highly overlapped. So if they are highly overlapped, then we are eliminating the activation of this unit. So this is good. So because after we treat the artifact classification unit, and these elimination or correction part are automatic. We don't have to manually see then which area should be eliminated and keep it or not. So then this is the result of what we apply. So when this is original GAN image and this is the eliminate by algorithm, so corrected by our algorithm. And this is the original image, and this is corrected by algorithm and so on, right? So then you can see that the original image can be well corrected by our algorithm. So this is the US blog that even before we present our work in the CVPR, and the blogger say plastic surgery book and generated face are made by Korean researcher, but we didn't say anything about plastic surgery in our paper. But South Korea is kind of famous for, especially the Gangnam area, it's famous for the plastic surgery. So the blog make this a fancy name of the article, and you can see that compared to the original image, our algorithm automatically correct the area which is not well behaved. So this is selected as one of the case to breakthrough research in last 4. And so one of our, like, actually we did spend a lot of time on this before making this, and I think actually we spent about more than 3 years to make this one. So our hope was to analyze the problematic unit which make artifact in unsupervised way. But if you see those images, then we have a supervised training of artifacts image or not, right? So that is actually, we hand manually train whether this image has artifact or not by our researcher. But we spend like a longer year to understand why this is made and why not and so on. So after we do this and we did like a study further, or we are like continuing study further, and we found some like two like kind of empirical observation that make this one. So one of the thing is, so some artifact unit has like geographic shape. So if you compare this, so this part in the red one is activated by unit 179, and the normal part in the lip is activated by unit 229. And if we try to choose the two highest activation axis, like feature, then we can see that those features are kind of peaked, meaning that, so those curvature are very peak, like it's like a very peak mountain, and so like a sharp mountain, so some of those activation is very sharp. So then we can see that those sharp, like a high curvature of these activation sometimes make artifact unit. And compared to the very smooth activation over the area and so on. So probably this would be the issue of some of the strong like learning, or like whenever we have like a training, then the special activation or special error backpropagation unit observe or meet this axis and making big or small or like a bigger change of the parameter and making this one. So to do this, we try to make the function, small little function like called the local activation. And the local activation is try to just compute the curvature of the neuron activation, and which is like kind of heuristic function to compute this activation with the number. And after that, so we can try to change the sample with the low curvature and the sample with high curvature. And then we observe that like a sample with low curvature is more stable, and the sample with high curvature, so at least some of the high curvature and those generation are like a more like a artifact with artifact. So that is actually what we actually found. And also in the other data set, and so low curvature is more stable, and high curvature is more like a kind of like artifact. But one thing that we actually observed that is, one thing that we observed that is, so typically low curvature is kind of tedious, meaning that the shape and color and their like pose are very similar. So if you compare the cat in the low curvature and the high curvature, and the low curvature, there are very few artifacts, but their size and the pose are very similar. Then the high curvature, and there are a lot of cat, but a lot of artifacts, but their shape are diverse. So what we observe that is, so actually there is our like ongoing research is, not only for the low curvature, like the low curvature is not always good because they make simplified generative image. So they may not make a very diverse image and so on. So then we are trying to make, like encourage to make this type of high curvature. And of course, in the simultaneously, the high curvature image are more stable generation without artifacts. So that is actually what we are pushing for, the creative generative AI direction. So high curvature is not bad, but sometimes the lack of training data and so on, so that we are trying to encourage high curvature with stable generation and so on. That is actually our current research direction. And also another one that we recently do is, so we actually did this research in the more like empirically verify whether this is the rare like good case, and the rarely activated neuron and the frequently activated neuron, and we compare that whether rarely activated neuron make more artifact and the frequently activated neuron make more artifact, and see that based on the activation rate and compare the artifact, and of course the like activation rate is like higher, then the artifacts get lower, and activation rate is lower, then we have more artifacts. So that is actually kind of common sense, mid common sense, so that if we don't have much training data, many training data meet to the specific neuron, then of course the neuron can be diverse, but because of lack of training data, the generation from that like a rarely activated unit maybe may include more artifacts. So because it's not really finished yet to train the generative model and so on. So like similarly, we sometimes try to like limit the like a rarely activated neuron are not activated more, then we can see that those artifacts are well corrected by this automatic algorithm by computing the activation rate and so on. Yeah, so then we can also see that the many images are correctly by this one. But of course, actually, our goal is not try to correct the image, but somehow we need to make quantitative or qualitative like evidence that our finding is good. So so that is actually what we are doing. But we are not aiming to like compete with like Adobe and so on to make a correction of the image and so on. So another like very important direction for the explainable AI is a kind of framework. Then the Meta has PyTorch Captain library, and Google has also like a TensorFlow responsible AI library. So that what we are trying to do is, so what we are trying to do is, so we are trying to make the like the framework in the second phase of explainable AI project, and so one of the one of the algorithms that are used by many like a researcher recently is, so I will try to explain from this one. So so input attribution algorithm like gradient time input or guided vector and integrate gradient and guided integrate gradient and full gradient and so on are common in a way that from the base point they try to change these values. So base point means that image is coming from either like a mean value or zero value, whether this part is not exist. Like, and then those values are increased somehow, the image is changed, and see how much individual like the image classification is changed and so on. So, but so like one thing is, so what we recently find is, so many of the image, this guided integrated gradient is the explainable AI engine used by TensorFlow responsible AI platform. So if you train your model with TensorFlow and run with the explainable AI toolkit, then the guided integrated gradient algorithm compute and getting you the response. And also PyTorch use a deep lift algorithm, but if you like in the academic area, academic comparison, the guided integrated gradient is better to compute the attribution in the image and the other part of one. But so this green area is the example what guided integrated gradient is do. So what guided integrated gradient is, so from the input to the like baseline to the input, the baseline is either the image whether there is no interesting part. Input image is the image that image has in the original space. But typically, what we do in the integrate gradient is try to find put the line between the baseline to the image and try to get the contribution, how much individual part improve the score for this part. And like guided integrated gradient is changing slightly to optimize the score from the individual part and so on. But what we recently found is guided ingredient was not that bad, but somehow defected region. How we can pass through the defected region is important, because like suddenly when guided ingredient pass through the defected region, a lot of noise like here are come up. So to solve this issue, we try to like pass through the individual internal unit which contribute to the contribution of this input part. So you can say that this input part has a lot of different units which is activated internally. So we try to pass through that actually more explicit way, not slightly different from the original this line, and then we actually compute this more clearly, and we find that our algorithm and is more robust to pass through the defected region, and we improve the score and also qualitatively like explanation compared to the guided integrated. So this will be presented in this new lips, and so if you compare the quantitative score and the qualitative like a result, and compared to the guided integrated gradient that Google has, and our algorithm is more important. But I think actually we didn't clearly understand what defective region and so on, but actually our idea. So probably the class object can be composed or classified with a small internal part, and try to divide those contribution of individual internal part like clearly would be better to compute the input like attribution better than the not dividing this part. But somehow this defective region is also the still unknown like issue that we may need to explore more. So like one issue is, so from the baseline to the input, and how we can pass through these individual decision boundary to maximize maximize or optimize our computation of input attribution is also mathematically still open problem, and we're fundamentally finding the baseline is still very like open problem in the explainable area. The baseline is, the typical baseline is 0 value from 0. So we are interpolation from 0 to the input image, and we are measuring the score, how this final classification results does change. But this is not really like semantically good way. So of course, actually, so when we recognize simple border, then from what point actually border is recognized people, or from what point is border is recognized specific neural network model is different actually story. So that like finding the good baseline, of course, in the semantically good baseline is this compared to this image. But we cannot actually eliminate this border, right? So that how we can make the practical good baseline is one of the still issue that, as I know that Professor Klaus Müller also tried to find. I'm not so sure he's very interested in this, but I'm very curious of this issue, and also many researchers we can also try to like find this baseline, how we can fundamentally find the baseline, how we can properly mathematically define the path from the input to the baseline to make the more accurate computation of input attribution in the further would be the issue that I wish to like hopefully collaborate. Yeah. So yeah. So I think so I should put Weekend here, right? Because I got the letter, but I forgot to put the icon of Weekend. Sorry. But anyway, so like we are making the next step for the explainable AI, which is to make the USB like explainable AI platform. But currently, like doing explainable AI need a lot of manual like work, so that we need to identify the model, and we need to find which algorithm can be applicable, and so on. So there is kind of head like ache, so that we wish to make a plug and play explainable AI. So when AI model come, with some standard as we use USB, then this model has like a comparable explainable AI algorithm so that this platform automatically recognize and like proving this internal unit and the verification and the providing explanation and so on is what we wish to do. And probably like many like active researcher are included in this project. This project is also huge, so including this all over 4 different like project that in the explainable AI team, probably I think 400 like researchers are included in this project. So I will try to briefly introduce my company and so on, and finalize my presentation. So then how we can use explainable AI? So there are many ways to use explainable AI. But in one of the mission critical systems that we wish to use explainable AI is the manufacturing. So manufacturing, so in like for in Japan, like Toyota and the semiconductor, like part, and also the robot maker and the control maker, and also Korea semiconductor and the electronics, and also steel making and so on. But so typically those manufacturing are very challenging because so we have high heat and the pressure corrosion. Because of that, we can put sensor inside of big reactor, and the lack of experience to site manager and the like increasing cost for the data analyst and also the AI experts. They are very expensive. So this manufacturing site cannot hire all of like expensive data analyst. And also we have a lot of sensor and operation mode change, and I'm not so sure for like I think it's Japan and Korea had issue for the increasing cost of the energy price and so on. That is very critical issue. So in it we are providing the AI based optimization solution. Now that is based on the prediction from the input to we try to predict the output. But because we in this training procedure, we can analyze the causal mechanism between the input and output, and we can try to give the better guidance to change the output, like quality and quantity of the product, how we can optimize the quality and quantity of the product with this AI model. Not only for this, and we are providing explainable AI toolkit to explainable AI actual toolkit to explain the decision of the individual control, and also based on the cost and cost save optimize cost to the production and so on. So these are our company is led by, of course, like my student and researcher did a great job to make this a lot of paper, and so some of them are actively used in the company, and we have some. So it is a little bit embarrassing to say the word leading technology in front of Professor Masashi Sugiyama, but in the weekend. But we have some like a cutting edge AI in the prediction and explainable AI and so on. And for one of the example that explainable AI technique that we are using is example-based explanation. So if we have a deep neural network for time series prediction, so as we do the network dissection, we wish to make the prototype example, which highlight this node, let's say the green, and which type of activation is typically highlight, and compare with individual sensor input like a black one. So then we compare the black one in the typical activation, how this current input is deviate, and so on is what we can see. So we can see that in this part, black one is a little bit earlier peak, and the yellow one is a little bit delayed peak and delayed down. And in the red area, then the black one is like a sharp, like a sudden increase and smooth decrease. But in the typical prototype is differently and so on. And also we can put the input attribution method on the time series data. For example, this group 22 is the pattern, and this blue is our input. Then we can visualize value hierarchy plot that we made. And so it is a little bit hard. So we can see that A and B and this part are important to be classified as group 22. That this is with respect to the deep neural network model. And but we are not so sure how much A is like more important than the B part. So we can see that some part in A are like a double time more important in terms of input attribution than the other part in B. So we can see that A is more important. So in this group 22 like classification, then twice than the B part, and so we can visualize and inspect our deep neural network. So we have like a extensive industrial experience, like high temperature reactor and the low temperature reactor. High temperature reactor is like a blast furnace and so on. Low temperature reactor is like a chemical reactor, and also using cloud-based AI. And has application to the many industrial area like steel making, like cement industry, glass melting, and petrochemical and traffic optimization, and so on, so that we reduce operation cost and improve the product or service quality and improve profitability. So we are like basically we let our customer make more money and is to get some part of it. So, but of course, actually, our customers should make more money and so on. But that is actually very trendy. So there is a little bit one. But so this is automatic system and hyper automation. Decision intelligence is very trendy, important strategy trend selected by Gartner. And also energy price is recently like suddenly increased, not only for Japan, but also for Korea, for all over the world. And if you see the oil and coal price, then the recent price is like a record high. So that as we have 40-year and the 50-year and so on, so that the record breaking high, so that we need some act in terms of AI to make our society better. So I will try to share some video and we'll finalize my talk, which already almost like past the time, but this is a little bit fun, so in Japanese, so then I wish you to enjoy. We may need to change the last name to the Japanese name. Sugiyama. Sugiyama. So yeah, there are some chemical and the scenario, but most of them are included in the video. So that I wish to thank for your attention and sorry for the like over of time.
Yeah, thank you very much for the nice talk. So the talk contains the three parts. Right? So the overview of the entire explanation, explain of the AI field, then so your technology, and finally industrial application. So all are quite interesting. So if you have any questions, please write it in the chat window, or you may speak it out. So let me start from a high-level question in the technology part. So I think your focus today was mostly images, but explanation is of course not only for images, but also any data. So can you think of extending your approach to other types of data, like signals or languages?
Yeah, so we are doing explanation for the image and also time series data. So, but they are kind of similar because they have CNN model are used. So, but in terms of like illustration purpose, then image is much easier to demonstrate. So there also one of the difficulty in the time series data is so semantic labeling of time series data is not much. So in the image, so we have a semantic segmentation and a lot of label, but so if you imagine the time series data and the signal, then each data and the stock data, current data, they all have different scale and different pattern. Of course, there is a pattern, but the UCR data kind of like a small data set. And also it's like my current concern is, so how we can semantically label different like meaning of time series data. That is actually like not solved yet because that's the reason why we are not demonstrating with time series data, but the similar approach can be used. But another like very important challenge also we spent about 5 years, but we could not.
This is definitely a challenging topic.
But that is challenging for the language model. So we are really curious about like when this language model, how we like a meaning is generated, connected, and so on. But transformer, like heavy attention, make the attribution of internal proving hard.
True.
Yeah, because actually they dynamically change their activation and attention in the individual level, and if they have different one and the selection, basically selection, right? Out of all the like a vector, at some time they are using only 3, sometimes 5, and all of different activation, and that make actually activation harder. So people call them the pathology, this type of research, but we have some like we are still trying to do, but that is actually much harder problem. But it should be done, I think.
Yeah, thank you very much. And I have one more question about the plastic surgery part. So that's quite nice. And in the case of image, so it could be regarded as face images, it could be regarded as plastic surgery. But if you apply that kind of technique to like other data, like signals, then it's a nice denoising technique.
Oh, sure, right.
Can we somehow use that technique not only for explanation purposes, but also for more like data analysis purposes?
Oh yeah, so like I didn't think about denoising part, but also so like the thing is, so what we have worry when we have actually the automatic correction is, so sometimes our grade cam image is masked, and also overlapping with another internal layer is kind of weak sometimes. So of course we have a conjecture hypothesis. Probably this unit may contribute to this artifact, but somehow this can be like overlapped by chance, right? Like not artifact generator unit can be made this one. But I think actually like a denoising technique or mathematical trick that verify whether this is like well connected in terms of covariance or other statistical measure would be good approach to make this more robust.
Yeah, that's good. Then so question by Ken Sato, can you speak out?
Thank you very much for your interesting talk. I'm a researcher in National Institute of Informatics in Japan, and I'm working on the AI and law. And I have two questions that in deep learning, you could get the explanation of result in terms of statistical analysis, but the explanation is not enough in some domains such as legal domain. For example, there is a work on prediction on legal judgment from legal case descriptions using some language models using BERT, for example. And we could get the explanation from BERT that some word is important in case description to contribute a legal judgment. But it is not sufficient in terms of legal reasoning because we need some legal explanation. And do you have any idea to overcome this kind of different kinds of explanation production?
Yeah, so that is very important question and the direction for the explanation. So using deep neural network or AI model to make a proper like a reasoning or like that is the reasoning. So that is in terms of making the like explaining like using explainable AI to make direct explanation generation. But so one of my opinion on that is so typically most of our ongoing like big language model are based on the search technique, meaning that so if you ask something, so we are not so sure the AI model, like a big language model, understands semantic, but they can try to search which seems to be similar, like a semantic in terms of original text data. So whenever we ask, so when is something happen or what is the place and so on, then where is the place and so on, then that information is extracted very well. But still, like not only for me, but also the researchers say, so these AI models are not very good in terms of finding a semantic relation, semantic language relation, meaning that when A do something B, and in this actually do is an asymmetric relation between A and B. But in the legal case, so we have to justify or examine whether A to B do the thing the B and the B actually do something C and so on. This sequential or like a relation or symmetric relation is very important, but as I understand, and many current AI model is not really good because they are not trained in that way. So to making a legal or more like a strict area to verify, I think actually this asymmetric relation learning is very important. Relation learning also the verification of this would be very important.
Yes, may I ask another question?
Yeah.
That you mentioned about GDPR, and there are abstract terms such as appropriate technical and organizational measures in GDPR. And I think it is difficult to check whether an IT company takes such appropriate technical measure for their product, since it is not a concrete measure. Do you know any research on how to produce an explanation that the compliance of this kind of abstract terms?
Yeah. So that is a really like a challenging question. So as I say that like there is an initiative to make an explainable AI standard, and also the like measure to explain is kind of a little bit behind the standard. So many people who are doing making standard had a hard time to make a proper measure for the correct explanation. But so that is actually like the explanation itself is really diverse somehow. Visual explanation and language explanation and also definition and so on. So we may need to somehow actually like define those measures correctly. But so one of the in terms of like my mind, so because I'm also operating the company and using explainable technique there, then our principle is we are providing explanation what customer requests, and try to like making our technique deeper So whenever they request the explanation, we could provide. So that is actually our first principle. So in a way that in the GDPR, the explanation part, I think actually which type of explanation the customer request is the most important one. Like either like as we see in the autonomous driving like a system, then if they request us to see as a visual or language and so on, then we should be able to provide a proper explanation. But explanation itself is one of the most important abstraction problem because sometimes we have thousands of words and the customer wishes to explain, please explain in less than 5 words. That is happening sometimes, right? then also when we actually explain to our kids, then explain as easy as possible. Then I think actually like explanation itself in the long term is fundamental, very like a challenging abstraction problem. But so it would be better to focus on our current customer and to satisfy their need.
Thank you very much.
Thank you.
Any other questions? If there's no further questions, then so please join me to thank Jessica again for the great talk.
Oh, thank you.
So as he mentioned, Weekend AIP and TICE have already partnership. But
Sure.
because of this COVID restrictions, our collaboration was rather inactive in the last few years, unfortunately. But this time he came to us. Hopefully we can have more communication and collaboration.
And workshop together.
Yeah. Okay, so thank you very much for joining us today. So that's the end of the online seminar. Bye-bye.